We're excited to talk to you today about SQL on FHIR, some of our previous solutions, and then some of our plans going forwards, learnings from our past implementations, things we want to change. My name is Avi Lesher. I'm a health informaticist at OneUp.
And I'm Fatema Maroofi. I'm a data engineer at OneUp Health.
So to start with, there's some kind of natural tension between FHIR and SQL, which is part of what makes this interesting, right? So FHIR is very flexible, but it has a lot of nesting, it has arrays, it doesn't always have consistent structure because it's so extensible, so different implementations may do things differently. And then SQL excels at analytics, but it expects a very regular structure. And so there's some ways to kind of bridge that gap or move the dial in between those two, but there's always some natural challenges that tension brings.
Okay, going right into it. So our first approach was using Athena. Athena is great because it's serverless and it's essentially zero ETL. All you need to do is have your FHIR JSON in an S3 bucket and have a schema defined in Athena, and hopefully with very little work, it'll seamlessly go through. But this does come with some costs. One being a financial cost. The financial cost of Athena is pretty unpredictable because the model is pay per query, so the more you query, the higher your costs go. Athena also came with a slow query runtime, primarily because Athena is schema on read, so the schema is applied only when a query is executed. Athena also doesn't work well with large nested JSONs, so the unnesting of that also comes with the performance cost. The biggest issue of them all is Athena's rigid schema requirements, which means that with these JSONs, we need to enforce or manually prune to a default depth. An issue came up with one of our customers where they were trying to access an NPI value of a practitioner, which was stored in an extension on their claims data. We, by default, pruned at depth 4, and of course, their NPI value was at depth 5. So when they were trying to access this data via SQL on FHIR, that data was missing and it was lost, and they were not able to access it, which is what led us into exploring other options, and that brings us to Redshift. So Redshift offers a great data type called the super data type, where you're just able to store your JSON as is. I like to think of super as a closet where you take your JSON bundle, you throw it in there, close the doors, and you don't deal with it unless you absolutely need to access something. Redshift also gives great access controls, so you can restrict a user's access down to a specific constraint on a specific column. So an example use case of this is needing to limit access on a user based on their claims data only to a specific insurer. Redshift is also more cost-friendly. It's pay per cluster type and number of nodes on that cluster, so you can query to your heart's content unlimitedly. It really incentivizes exploration, which I think is important in an analytic tool to not be limited by cost or be worried about cost and query and explore. Redshift also performed faster compared to Athena, mainly because of its schema on load. The schema is enforced when the data is loaded, so that happens before querying. But Redshift comes with the fact that you need to have a full-on ETL pipeline maintained and deployed into your customer environments. This is a simple example of how we can unnest the super data type in SQL. As you can see, Redshift leverages a more typical dot notation to parse this JSON. This is something that our customers really liked with Redshift compared to Athena. Athena uses the famous cross-join unnest statement, which a lot of even advanced SQL developers are not very familiar with.
So some of the use cases for using SQL on FHIR, there's a number of queries that a payer might want to run across their data where it's nice to have a more complete set, especially for some of the smaller to mid-sized payers that we're working with. They might not have all of their claims data in one place that's queryable easily. So they want to do something like identifying the mental health medications that are missing corresponding mental health diagnosis codes, or a vaccine that might have been missed as part of a multi-course protocol. SQL on FHIR can be a nice way to do that. Another example might be like a transition of care where they want to produce a list of elderly individuals that were discharged from hospitals after being admitted because of a fall. Another use case that we saw a lot of people picking up was just generally trying to assess their data quality. So a lot of clients are much more comfortable working with a relational database and using SQL than querying a FHIR server. And so that was a good option for them to conduct UAT, see that everything they expected to be in their FHIR resources was making it there. And then internally, there were also a lot of users where it was easier to direct some of our engineers to SQL and FHIR if they want to do something like assessing referential integrity, fill rates, or like the distribution of different codes within a field, than having them try to pull that from the FHIR data directly.
So one of the biggest challenges was maintaining the ETL pipeline work and deploying to our customer environments. So we really leveraged containerized deployment like Terraform to manage this. You can also tap into the world of multi-tenancy and use multi-tenant clusters to reduce deployment duplication that you would have if you were using single-tenant clusters.
The other challenges that we ran into were largely in the earlier part of the pipeline, even before we got to FHIR. So just inconsistency in the data coming from inconsistent data mappings and sources. So we've tried to do more to kind of validate the data earlier in the ingestion and shift left with a lot of that validation. Not only doing that at the FHIR validation stage, but also doing like some schema validation and enforcing more about what we expect from some of these data types. And then the other piece was kind of just being able to better troubleshoot new deployments. And so some of our new infrastructure has a lot more snapshots along the way, both of the raw FHIR right before it gets put into the analytics zone, as we're calling it now, and for the earlier stages. So, loading the data in, then transforming it, and having potentially even an intermediate stage, and having tracing data along the way so that we can better troubleshoot. Whereas in the past, trying to find the FHIR resources that were corresponded to specific rows in the database was more challenging than you might expect. So as we're looking into the future and thinking about what we want our next iteration of SQL and FHIR to look like, we're starting to experiment more with some of the things that others working with SQL and FHIR have been doing when it comes to actually flattening the data and trying to get more benefits out of a more typical relational database structure as opposed to shoving things into closets like we said before. So we're experimenting with some ideas like that along the lines of view definitions that others are using. And at least in our current iteration, we still have some of those JSON snippets so that we can make sure we're not losing data elements that might be in unexpected places within the FHIR. We're also building with more metadata in Lakehouse architecture, which gives us a lot more options when we're going to flatten the data. We can potentially make little tweaks based on the data source to make sure that we're pulling out some of those data elements. Still remains to be seen how much we're actually going to use that in practice, because there's some obvious kind of trade-offs there in terms of time and effort actually being worth it. But definitely, if we have large quantities of data that have a different structure, it's a nice option to have available to us. We also want to start to leverage SQL and FHIR more than we were in the past. So we want to use it for potentially richer integrations, especially if we're working with a client who has a vendor that wants to connect to them that might not be as comfortable with FHIR. It could be a good option to give them access to some of this formatting of the data where they can more quickly look at the table structure and understand what the data elements are. And we also can do some really fine-grained controls, access controls with SQL and FHIR more easily than we could with the FHIR data. We're also looking to use it for analytics, obviously. So one of the goals of our new approach is to build a more flexible infrastructure where we can convert it into different formats of data and potentially try out new things with different customers as pilots if they have some data model, data mart project that they want to try out using their FHIR data as the basis.
So you can contact us here. My email's on there, and that link should hyperlink to my LinkedIn. So please feel free to connect, send an email. I'd love to chat if you have any questions. And we can go on to Q&A.
Thank you. Thanks for the great presentation. So two hopefully quick, related questions to each other. So when you convert your FHIR data into flat tables, basically, how do you deal with missing columns, basically, meaning that there was something in, because it is going to be a lossy transformation anyway. If I understand correctly, you materialize basically those views. And then if you need something that is missing from the original, how do you deal with that? And then hopefully related to that, do you expose this to end users or no? You know what queries you are going to, what information you want to extract from FHIR data, and so missing data is probably less of a problem.
Yeah, so for the first piece around kind of flattening the data and what we're thinking, I think I mentioned this earlier when we were on this slide, but at least in our current iteration, we're going to maintain some of those JSON snippets alongside the flat data so that clients can still find the data in here, whether internal or external users. And in our previous iterations of SQL on FHIR, it hasn't been deployed for all of our clients, but we have allowed direct access to that data to work with it. And I expect that to continue into the future, although I think we want to do a lot more with giving internal users access to that and using it to kind of like fuel dashboards or build out specific queries as well. Yeah, I guess it's not in this picture, but I can go, it would essentially be like a combination of something like this with the flat data. So you might have explicit fields for different pieces of the name and then also have the name as a JSON snippet alongside that.
Any other question? Yes?
Can you maybe explain a bit about query complexity and at what point what is possible, essentially? So if you have your initial JSONs, you convert them using SQL on FHIR into some table format, and then you use your own version of SQL on FHIR. Like, how does it work, and what kind of queries can you actually ask your system, and where is the limit in terms of complexity with joins across resources and other things like that?
So with the current architecture with Redshift, the limitation would be based on performance, right? So when you're unnesting these JSONs, the more you unnest, the more you access, the slower the performance gets. Because essentially, when you are sort of accessing the element, you are doing a join on the same column, right, to unravel and go into the JSON. In terms of the new architecture?
Yeah, and in terms of the new stuff, I don't think we have a good understanding yet of what queries are going to be performant and possible. But at least theoretically, it should be a lot more performant once we have a lot of these fields unnested into a more traditional flat structure. And I think the access mechanism should allow us to execute most typical SQL queries. Yeah, that's right. This is not the same as the official SQL on FHIR implementation. We're taking like some pieces from it, but the actual way that we're flattening the data will be probably a different mapping.
But then trying to apply view definitions on it is coming back to the SQL on FHIR IG.
Yeah. I should say, I don't know that we're going to be using exactly view definitions because we're not publishing it in IG. There's not as much reason for us to kind of format that as a FHIR structure, but it's the same core idea of like saying, here's where we want to look in the FHIR to pull this specific data element name.
Okay, we do have a minute for another question. And if not, thank you everyone for attending and thank you for the presentation.
Thank you.